All right, this is section 3.6, talks about radical and quadratic inequalities. Okay, so these have a lot of steps to them. Okay, but we're doing the same thing over and over again. All right, the first thing that we're going to do is we're going to write the polynomial inequality in standard form. That means it's going to be factored, and your right hand side is going to have 0 on it. All right. Step 2 is we're going to find the zeros of the numerator and denominator. Okay, so that won't be too hard. Then you're going to plot those zeros on the number line, dividing the number line into intervals and naming them. You'll choose a test number from each interval and then construct a true and false chart. Okay, so I know that was a lot of words. All right, let's use those steps in an example. Okay, and these notes might be a little blurry, and I apologize for that. I'm gonna write it over again over here. X squared minus 3 is greater than or equal to 2x. Okay, so your first step is to write the polynomial inequality in standard form. That means that it's factored and the right-hand side has 0 on it. Okay, well, right now it has 2x on it, so let's move it over. Okay, let's subtract 2x, and I'm going to put it in descending order. So I have x squared minus 2x minus 3 is greater than or equal to 0. So I have 0, but now I need to factor it. Okay, this is an easy trinomial. X and x, my signs are different. And I need a 3 here and a 1 here. All right, so that's step 1. Polynomials in standard form, factored, and your right-hand side has a 0 on it. Okay, step 2 is finding the zeros of the numerator and the denominator. Okay, so I'll draw a line. Okay, so this will be step 2. Okay, you're going to set your numerator equal to 0 and your denominator equal to 0. Okay, for this one, we don't have a denominator, all right? We have x plus 1, x minus 3, no denominator, okay? So that side will be blank. If we had one, we would just set it equal to 0. But here we have x plus 1 equal to 0, so we get x equals negative 1. And then x minus 3 equals 0, so x equals 3, all right? That's step 2. I found the zeros of my numerator and denominator, all right? Step 3, we need to put these on a number line, okay? So here's our number line. And I need to put those zeros on my number line. So let's say negative 1 is right here. And let's say 3 is right here. Okay? Now, I need to name all these intervals. Okay, what intervals, you may ask? Here's an interval. Here's an interval. And there's an interval. Okay, I need to name those. All right. If I'm putting something in interval notation, I'm using brackets and parentheses, right? That's what that means. Okay. So how do I know when to use brackets and when to use parentheses? Okay. Going back up here to step 2, your numerator. Your symbol depends on the problem. Okay, these are going back to your regular rules, right? If I have an equal to sign, I use a bracket. If I don't have an equal to sign, I use parentheses, okay? Whichever one you have is what you use, okay? This has greater than or equal to, so I use a bracket. So wherever I see a negative 1 and a 3, which is the only numbers I'm going to see because I don't have a denominator, I'm going to use a bracket. Okay, your denominator will always use a parentheses. I don't think a parentheses is a word. I think it's just parentheses. A parentheses. Okay, you will always use parentheses on your denominator. So if we had one, whatever that number was, we would use parentheses on it. All right. But these numbers are just our zeros for our numerator. So we will use brackets whenever we name our intervals. Okay. So this interval on the very left goes from negative infinity to -1 with a bracket. Our middle one is from -1 to 3, and our last one is from 3 to positive infinity. Okay, you should have no trouble with that after what we've talked about with inequalities. Okay, now last step, you're going to choose test numbers. Okay, you're going to build your true and false chart. True and false chart. All right. You're going to use your standard form of your inequality. Our standard form was x minus 3, x plus 1 is greater than or equal to 0. Okay. This is where I got that from. I can highlight it for you so it doesn't seem random. Okay. That's where I got that from. And so I'm going to pick a number in this interval, and I'm going to pick another one in this one and another one in this one. And I'm going to see if I'm going to plug that in for x, and I'm going to see if I actually get something that's greater than or equal to 0. If I do, then it's true. If I don't, then it's false. Okay. So we can be smart about what we pick, right? I'm going to pick -2. If you want to pick -100, that's perfectly fine, but you are the one that has to plug those in and multiply them out. All right. So that's why it's just smart to pick those numbers. Okay. So we'll pick that x equals -2. Okay. So we'll plug it in. We'll get -2 minus 3 times -2 plus 1 is greater than or equal to 0. Okay. Let's see. We get -5 times -1 greater than or equal to 0. So that means that 5 is greater than or equal to 0. Okay. So is 5 greater than or equal to 0? Yes. So it's true. Okay. Now pick something in this middle interval. All right. It's always going to be smart that if you have 0 in your interval, pick it. Okay. So we'll pick 0. So 0 minus 3 times 0 plus 1 is greater than or equal to 0. So you get -3 times 1 is greater than or equal to 0. So is -3 greater than or equal to 0? No, that is false. Okay. Last one, we can pick 4. Again, if you want to pick 1,000, you can, but you are going to have to calculate that. Okay. So we'll get 4 minus 3, 4 plus 1 greater than or equal to 0, which is 1 times 5 is greater than 0. So is 5 greater than or equal to 0? Yes, true. So we can go back up here. All right. And we got true for this interval, false for this interval, and true for this interval. Okay. Our answer only includes the true statements. Okay. Only includes the true statements. Okay. So this would be your intervals of -infinity to 1, and you're going to union that with your other true statement because you have 2, 3 to positive infinity. Okay. So here's what I found. I solved the inequality, and I'm saying that any numbers from -infinity to -1 and 3 from 3 to positive infinity, that will give you an answer that is true to your inequality. Okay, those are all of the numbers that you could plug in and get a true statement. Okay, that's what we're finding. So we did standard form, numerator and denominator equal to 0, number line, named our intervals, true and false chart, filled out the chart, found our true statements. Okay, so I know that's a lot of steps. All right, so let's do this one. Here we do have a denominator. Okay, again, sorry that it's blurry. I can write over it maybe. Make it less blurry. Okay. X minus 3 over x plus 7 is less than or equal to 0. All right, so let's start by standard form. All right, now standard form means right-hand side has a 0 on it. That's true, we're good there. And it's factored. Okay, we cannot factor x minus 3 and x plus 7 any more than it already is. Okay, it's already factored, so we're good. Step 1 is done. Okay, step 2, your numerator equal to 0, your denominator equal to 0. Okay, numerator is x minus 3, denominator is x plus 7. Okay, so x equals 3, x equals negative 7 is what we get. Okay, number line. So here's negative 7 over here. And here's 3. All right, we need to name our intervals, but we can't do that without knowing brackets or parentheses. So we know our denominator is going to use parentheses because that's the rule, right? Always use parentheses. Always use parentheses. So wherever we write a 7, a negative 7, we'll use parentheses. This one depends on the problem. Okay, we have a less than or equal to sign. That tells us bracket because it's equal to. So wherever we use a 3, we will use a bracket. All right, so this interval would be negative infinity to negative 7, and we're going to use parentheses. This one will be negative 7 to 3, and we'll use a bracket on 3, and then 3 to infinity. Okay. Now we do our true false chart. Okay. And we have x minus 3 over x plus 7 is less than or equal to 0. All right. So let's pick negative 8. So we say negative 8 minus 3, negative 8 plus 7, less than or equal to 0. So we get negative 11 over negative 1. So is 11 less than 0? No. Okay, false. Let's pick 0. Okay, that's always a smart one to go with. 0 minus 3 over 0 plus 7 less than or equal to 0. So we get negative 3 over 7. So is negative 3 over 7 less than or equal to 0? Yes, this is true. Okay, it's negative. Doesn't matter that it's a fraction. Don't let that scare you. It's still negative, so it's still less than 0. Okay, now let's pick 4. 4 minus 3 over 4 plus 7 less than 0. So we get 1 over 11. So is 1 over 11 less than 0? No, it's positive. So that's false. Okay. So what did we get? We got false, true, false. So we got false, true, and false. Okay. Remember, your answer only includes the true statement. So your answer this time is just one interval, and it's -7 to 3. Okay. So that's your only answer this time. So no union. Okay. Here we got false, true, false. Over here we got true, false, true. Okay. All right. Let's do this one. We have, I'm going to write over it, x plus 1 over x plus 3 is greater than or equal to 2. Okay. It's our third example. We need it to be in standard form, which means 0 on the right side and factored. Okay, so we need to move this 2 over. So we get x plus 1 over x plus 3 minus 2 is greater than or equal to 0. All right, so we need this to be factored. Well, we need to get a common denominator. Okay, so our common denominator would be x plus 3, right? So we're going to multiply, right? We would want x plus 3 over here. So we're going to multiply by x plus 3. Let's write this over one term of x plus 3. Here we go. X plus 3. So we have x plus 1 minus 2x minus 6. Where did I get that from? I distributed my -2 through. Okay. -2 times x is -2x. -2 times 3 is -6. Greater than or equal to 0. Okay. We have some like terms. So we say -x minus 5 over x plus 3 greater than or equal to 0. Okay. End of step 1, right? Only difference with this one and the other ones is we had to find a common denominator. Okay. Now we need to do numerator equal to 0, denominator equal to 0, right? So we have -x minus 5 equals 0 and x plus 3 equals 0. So we get -x equals -5. I meant +5. We're going to add 5 to both sides. So I should have gotten. Then I'm going to divide by -1 to get x by itself, not -x, and get -5. And then we will subtract 3. X equals -3. Okay. We can go ahead and put parentheses for this one. We know we're about to put it on a number line, right? And name those intervals. And then we know that we will have brackets here because of the equal to. All right. So let's throw that on a number line. All right. -5 would be here. -3 would be somewhere right here. Let's make those lines a little bit more even. All right, let's name our intervals. We are here with -infinity to -5, and we will do brackets on -5, -5 and -3, 3, -3 will have parentheses, -3 to infinity. Okay. Now we need to do our true false chart. And we are using -x minus 5 over x plus 3 is greater than or equal to 0. All right. That's what we're going to plug in. All right. So let's use -6. So we'll do -6. Okay. You got to be careful right there. Minus 5 over -6 plus 3 It's greater than or equal to 0. So you get positive 6 minus 5 over negative 3. So that is 1 over negative 3 greater than 0. Is negative 1/3 greater than 0? No, that's false. It's negative. Definitely not greater than 0. Okay. If I asked you what number you would like to choose between the interval of -5 and -3, you would probably blurt out 0. Okay. Because that's what we've done the past two examples. 0 is not in this interval. Okay. We need to pick -4. Okay. So you got to be careful about that. Okay. So we get 4 minus 5 over -1. So that gives us -1 over -1. So is 1 greater than or equal to 0? Yep. Okay, let's do the last one. Now we can pick 0. Okay, 0 would be like right here. -3 to infinity, 0 would be in that interval. So we can pick 0 for that. Okay, so is -5 over 3 greater than or equal to 0? No, false. It's negative. So we got false, true, false. All right, so our answer is -5 to -3. Okay. -5 to -3 is our answer. All right, notice how we got false, true, false, false, true, false, true, false, true. Notice how they alternated. All right. These are always going to alternate unless we have something like this special case. Okay. These are always going to alternate unless we have something like this. Okay. And it'll make sense here in a second. Let me write it over. Okay, and this is a special case. All right, so this is in standard form. It's factored, right? We're good. All right, numerator and denominator equal to 0. Okay, all you want is when this equals 0. Okay, that's all you want. So you don't have to do x plus 4 squared equals 0. You just have to do x plus 4 equals 0 and find where that is. Where does that give us 0? Okay. And then you have x plus 6 equals 0. So that's -6. And then you have x minus 3 equals 0. And that gives us 3. Okay. So we can just go ahead and say parentheses. And we can say brackets. Okay. Brackets. Okay. Let's put them on a number line. All right. So we have -6, -4, and 3. Okay, let's name all of these intervals. So we have more than 2. This time we have 3. -infinity to -6. -6 has parentheses. -6 to -4. -4 to 3. 3 has parentheses. All right. Great. So now we have this. So we would do a true false chart, right? And we would use x plus 4 squared over x plus 6, x minus 3, less than or equal to 0. Okay. I'm going to save us some time here. And we would pick numbers, we would plug them in, and we would get false, true, true, false. Okay. Now, notice how I just said, okay, we have, they alternate whenever on most cases, but they're not going to alternate here. They didn't alternate because of multiplicity. Okay, let me pick a color. So -4 has multiplicity 2. Multiplicity 2. Okay, notice I get that from here, right? X plus 4 has multiplicity 2. So your true false sections do not alternate. All right, they don't alternate. So what does that mean for us? All right, it doesn't alternate on the multiplicity line. Okay, here's where we have multiplicity. You'll have alternating here and you'll alternate here, but these will be the same. Okay, sorry if you just heard someone come in the room. Close the door. Okay, these will alternate across that multiplicity. They'll be the same. Okay, so you would have, if you had true here, you would have false, false, true. Okay, so it doesn't exactly alternate, but there still is a pattern that you'll see if you have multiplicity. All right, so your answer for this would be -6 to -4 union -4 to 3. Well, if you look at that hard for a second, you would see that it's just this entire interval. It's the interval from -6 to +3, right? So you could write it as -6, comma 3, either one, because of that multiplicity. Okay, but that is a special case whenever you do have multiplicity. All of the other instances are going to alternate, right? So that's a good way for you to check yourself. If you are working a problem where you don't have multiplicity, you should be alternating. So if you right here got false, false, true, you would know something was up here and here. Okay, so it's a good way to keep your stuff straight. Okay, but it all comes back to these 5 steps. Okay, and that's 3.6.